You are moving through space at 600 kilometers per second. Not orbiting, not rotating, moving. Your entire galaxy is caught in a current you cannot see, rushing towards something massive enough to drag a trillion suns across the void. This is not theory, this is measurement. When astronomers mapped the afterglow of creation itself, they found proof written in the oldest light in the universe. The cosmic microwave background radiation is hotter in one direction of the sky than the other. This is the Doppler effect operating on a scale so vast it defies comprehension. You are watching the universe's speedometer, and it reads 600 kilometers per second relative to the cosmic rest frame. Something is pulling the Milky Way, Andromeda, and tens of thousands of neighboring galaxies toward a region of space we call the Great Attractor. But here is what most documentaries will not tell you. The attraction is only half the story. There is something behind us, pushing. The discovery begins in 1986. 7 astronomers, a team that would later be nicknamed the Seven Samurai, publish measurements that shake cosmology. Donald Lynden Bell, Sander Faber, Roberto Terlevich, David Burstein, Roger Davies, Alan Dressler, and Gary Wedner compile peculiar velocity data for elliptical galaxies. They expect a random motion, they find coordinated flow. Hundreds of galaxies are moving together, like leaves on a river. They are not just orbiting the local gravitational landscape. They are being carried by a current they call the dark flow. The measurements converge on a specific region in the southern sky, in the direction of the constellations Triangulum Australe and Norma. The mass required to generate this motion exceeds anything visible in our telescopes. They calculate it must equal tens of thousands of Milky Way galaxies concentrated in a relatively small volume of space. They name it the Great Attractor. The Great Attractor sits directly behind the plane of the Milky Way. It is hidden in our blind spot. The zone of avoidance. Astronomers use clinical terminology for a profoundly frustrating problem. Our galaxy is a disk. We live inside that disk. When you look toward the galactic plane, you are staring through 100,000 light-years of gas and dust. This material absorbs visible light almost completely. For decades, the Great Attractor existed only as an inference, a gravitational ghost detected through its influence on surrounding galaxies but never directly observed. Optical telescopes are useless. The dust layer is too thick. Radio astronomy offers partial relief. The 21-centimeter line of neutral hydrogen can penetrate the obscuration, revealing some structure. X-ray observatories detect hot gas in galaxy clusters behind the veil, but the data remains fragmentary, incomplete. Imagine investigating a crime scene where the primary evidence is hidden behind a wall you cannot remove. You must reconstruct the perpetrator from footprints, shadows, and testimony of witnesses. This is cosmic forensics. The monster is hiding in your blind spot, and you know it is massive enough to drag you across the universe. The psychological horror is deliberate. We are moving towards something we cannot fully see. In 2014, a team led by Brent Telly publishes the first complete map of our cosmic neighborhood. They name it Laniakea, Hawaiian for immeasurable heaven. This is not just a galaxy cluster. It is a gravitational watershed. Think of rainfall on a mountain range. Water flows downhill, carving channels, merging into streams, converging into rivers that eventually drain into a single basin. Laniakea operates on the same principle, but the terrain is curved spacetime, and the water is made of galaxies. The structure contains 100,000 galaxies with a total mass of 100 million billion suns. It spans 520 million light-years. We are not at the center. The Milky Way sits near the outer edge of this basin, flowing inward along with everything else. The Great Attractor marks the drainage point, the lowest gravitational potential in the local region. All galaxies in Laniakea are sliding down the space-time gradient toward this nexus. But Tummy's team discovers something crucial. The peculiar velocities do not perfectly converge on the Great Attractor. There are deviations, residual motions that cannot be explained by gravitational attraction toward a single mass concentration. The galaxies are not just falling toward something, they are also moving away from something else. This is where the story breaks from conventional telling. In 2017, a team led by Yehuda Hoffman announces a discovery that completes the puzzle. There is a massive void behind us. Not just empty space, but a region where galaxy density is significantly below cosmic average. They name it the Dipole Repeller. The void is not pulling. Voids do not pull. But in an expanding universe governed by dark energy, The physics becomes subtle and profound. Regions with high matter density resist expansion more than regions with low density. The void is expanding faster than the surrounding cosmic web. The differential expansion creates an effective push. Galaxies on the edge of the void are not attracted to denser regions. They are repelled by the void's accelerated expansion. You are not just falling toward the Great Attractor. You are being pushed away from the dipole repeller. The current that carries the Milky Way is generated by both forces operating simultaneously. This is the missing link in the theory. The peculiar velocity field of the local universe is a dipole structure, a push from one side and a pull from the other. We are surfing a gravitational wave created by density contrasts in the cosmic web. The void is 7 billion light-years away in the opposite direction from the Great Attractor. The symmetry is not coincidental, it is structural. The universe organizes itself into filaments, walls, and voids. High-density regions grow by accreting matter. Low-density regions grow. Radio surveys and X-ray telescopes eventually pierce the zone of avoidance enough to reveal the first direct evidence: the Norma cluster. This is what was hiding in the blind spot. Thousands of galaxies compressed into a region roughly 10 million light-years across. The mass concentration is staggering, 1 quadrillion times the mass of the Sun. But this is not the Great Attractor. This is the signpost. The Norma cluster is one component of a larger structure, a cosmic traffic jam where multiple galaxy groups have collided and merged. The gravitational field is so intense that space-time itself warps measurably. Light from background galaxies bends around this mass, creating gravitational lensing arcs visible in deep surveys. But even Norma is not massive enough to explain the full magnitude of the dark flow. The peculiar velocities are too large. The motion involves too many galaxies across too wide a region. Norma is a waypoint, not the final destination. The trail leads deeper into the cosmic web, beyond the immediate obscuration, toward a structure so massive it makes the Norma cluster look small. The true Titan hides 650 million light-years away. Carlos Shapley discovered this structure in the 1930s while conducting a survey of galaxy distributions. He noted an unusual concentration of galaxies in the constellation Centaurus. Decades later, astronomers realized what Shapley had found: the largest known concentration of mass in the nearby universe. The Shapley Supercluster contains more than 8,000 galaxies in its core region. The total mass exceeds 10 million billion suns. It is one of the most massive structures within 1 billion light-years of Earth, and it sits directly behind the Great Attractor, along the same line of cosmic flow. This is the monster behind the monster. The Great Attractor itself is being pulled towards Shapley. The hierarchical structure of gravitational attraction extends across hundreds of millions of light-years. Small galaxies fall into groups, groups fall into clusters, clusters fall into superclusters, and superclusters fall toward the largest density concentrations in the cosmic web. Shapley is one of those ultimate attractors. The Dipole repeller pushes from one direction. The Great Attractor pulls from the middle distance. Shapley pulls from the far end. The Milky Way is caught in a nested series of gravitational currents, each one driven by progressively larger mass concentrations, operating on progressively larger scales. This is the full picture. Not a simple fall toward a single point, but a complex flow through a multi-scale cosmic web architecture. Now comes the tragedy: dark energy. The cosmological constant, the mysterious pressure that drives the accelerated expansion of the universe. Gravity is trying to build larger structures. It wants to pull Laniakea into Shapley, to merge superclusters into hyperclusters, to assemble ever larger cosmic architectures. But dark energy is working against gravity. It is not a force in the traditional sense. It is a property of space itself. As the universe expands, more space is created. That new space carries its own dark energy density. The expansion accelerates. On small scales, gravity wins. Solar systems remain bound. Galaxies remain bound. Even galaxy clusters remain bound. But on scales larger than superclusters, dark energy dominates. The space between Laniakea and Shapley is expanding faster than we can cross it. We are moving towards Shapley at 600 kilometers per second. But the space between us and Shapley is expanding at an even faster rate. We will never arrive. This is not a failure of motion. It is the fundamental physics of an accelerating universe. The cosmic horizon shrinks with time. Galaxies that are currently visible will eventually be redshifted beyond detectability. Their light will stretch to radio wavelengths, then to wavelengths longer than the observable universe itself. They will not disappear in an instant. They will fade over billions of years, like ships sailing beyond the receding horizon. You are part of a cosmic migration that will never reach its destination. The Great Attractor pulls you forward. The Dipole Repeller pushes you from behind. Shapley calls from a deep distance. But dark energy ensures that the journey has no endpoint, only an asymptotic approach. In 150 billion years, assuming current cosmological models hold, the Milky Way will have merged with Andromeda and other local group members. That merged structure will remain gravitationally bound, but everything beyond the local group will have expanded beyond the cosmic horizon. Laniakea will disperse, the Great Attractor will fade into the expanding void. Shapley will reshift into invisibility. Future civilizations in that merged galaxy will look out and see nothing. No distant galaxies, no cosmic microwave background with sufficient detail to infer the Big Bang. No evidence that the universe is larger than their own gravitational island. They will live in a cosmos that appears static, eternal, and small, unless they preserve the records. Unless they remember that once, their ancestors could see across billions of light years and map the currents that carried them through the cosmic web. This is the full story of the Great Attractor. Not a simple tale of gravitational pull, but a forensic investigation revealing a complex interplay of attraction and repulsion, density and void, gravity and dark energy. You are caught in a current between forces operating on scales your mind cannot easily grasp. You are moving at 600 kilometers per second toward a destination that retreats faster than you approach. The universe is not just expanding, it is accelerating away from any possibility of complete cosmic connection. The Great Attractor is not a destination, it is a direction. The journey itself is the only reality. The handshake will never happen.